Hey there, my name is Alejandro, and welcome back for day 188 of me doing the Daily LeetCode challenge until I reach 1 year's worth of good contributions here on GitHub. So today's problem is for January 20th, 2025. Without further ado, let's get straight into it. Okay, today we get LeetCode medium problem 2661, first completely painted row or column. You're given a zero indexed integer array R and an m by n integer matrix mat. Sorry, I can't read today. Okay, zero index integer array R, m by n integer matrix mat. Okay, R and mat. Okay, R and mat both contain all the integers in the range 1 up to m times n. Okay, so R is probably just a flattened version of mat, or maybe a reshuffled version. Okay, go through each index I in R, starting from index 0, and paint the cell in mat containing the integer Ri. Okay, return this. What? Go through from index 0 and paint the cell in mat containing the integer Ri. Return the smallest index I at which either a row or column will be completely painted in mat. Okay, so essentially, like, this is going to be one of those problems where we go through things in phases, right? M times n is linear. Yeah, exactly. Yeah. We can go linearly based off m times n, which is great. And then at the end, we just got to make sure that we count whether or not things are valid, right? So, like, for each row, we might have a hash map of, like, things that are painted in that row. And it's like that when you're a hash map, it's like, it'll make sense. Okay, now the only thing is, let's look at an example. R is 1342, mat is 1423, output 2. The moves are shown in order, and both the first row and second column of the matrix become fully painted at R is 2. So the point is, every single one, then 3 gets painted. So my idea, so step 1, okay, idea, loop through all elements in mat and use a hash map to store the values and have them to their position in mat. Then we can loop over R and paint things on the go using O of 1 look up times with the hash map. Then every time we paint something, we add that to its corresponding row and column painted positions. Any point a row contains n painted positions, or a column contains m, so here we'll do m comma n equals length of mat of 0, n painted positions, or a column contains m painted positions. We know we are done with the problem. And at that point, return the current index we just used to paint with last and bar. And at the very end, so at the very end, you'll end up, like, painting everything in the matrix, so there's guaranteed to be a solution. Okay, so step 1, okay, so this is gonna be a nice and chill problem, which is definitely very well, definitely a good break since yesterday's monster hard, right? So this is a LeetCode medium, which is basically like 3 chained LeetCode easies all at the same time, making it a LeetCode medium. Okay, makes sense. So here we'll go loop through mat, mapping val to position indeed is equal to this. I in range m, or j in range n. Here we'll say Okay, so yeah, since values in math are strictly 1 comma m times n, there are no duplicate values. To do, this means we don't even need a dictionary / hash map, can just use an array. In fact, yeah, so instead of a hash map, we'll say d is equal to -1 times m times n. Say d of val is equal to mat of ij, d of val equals I comma j. None. There you go. Print f string d equals, and then here return -1. Ah. Oh no, m times n plus 1, right? Yes, that's fine. Yeah, so this I expect to be faster. To do, yeah. So here for now, we can just, yeah, let's just make things a hash map for now. So now, for now, we'll just make things a hash map, but then we can use a linear array. Right, so for now, yeah, index 1 points to that. Value, so yeah, so 1 points to 0, 0. 4 points to 0, 1. 2 points to 1, 0, and 3 points to 1, 1. This is good. Then essentially, we're going to have a hash map. We have m rows and columns. Step 2. We need to create a unique dictionary for each row and each column linked to number of painted positions in that row / column. Yeah, okay, step 2, yeah. So here we'll say 2 rows is equal to default dict of int, columns default dict of int, for I comma val in enumerate r, index comma val, where here we'll say I comma j is equal to d of val, rows of I plus or equal to 1, rows of I equals m, turn I. Return index plus or equal to 1 if columns of j equals n. Actually, there should be n elements in the row, or m elements in the column, and here was return index. You'll say, or columns of j, raise exception, unreachable code. All right, does something like this work? Okay, this works. This is accepted. Let's submit. And there we go, completion streak 188 days, consistency is key, see ya tomorrow. Very nice. Okay, so yeah, so now we're here, be 37%. So yeah, there's probably some things that we can do to make things faster. One thing is straight up just using an array, right? This will work, I would presume. Yep, so let's submit that. Yeah, so that makes us to 65%. And then something like this, we can do the same thing, right? Rows, comma, columns is equal to 0 times m and 0 times n. Well, yeah. Nice. Okay. So if we submit that, something like that, is this faster? Yeah, so now we're at 98.11%. So yeah, use arrays whenever you can instead of hash maps, even though things are O of 1. There we go. Nice. Okay, nice. We can remove some of this stuff. There we go. There's exception on reachable code. Unreachable code. Yeah, we'll leave the raise exception part, fine. Makes it clear what I'm doing. Nice. Yeah, and that way I don't have to do -1s. That's why I do this. Okay, yeah, we'll just submit this one more time. And there we go. So we have a nice and efficient solution. Bada bing, bada boom. Very nice. Okay, so as always in all my videos, I do a quick recap if I was able to solve the problem. So this one, essentially, you're given a 0-index integer array R and an m by n integer matrix mat. They both include all the numbers from 1 to m times n, and exactly once for each, right? So they're both of size m times n. One of them is an array, one of them is a matrix, right? And here they want you to go through every single index I in R, starting from index 0, and paint the cell in mat that contains the integer R of I. Return the smallest index I, in which either a row or a column will be completely painted in mat. Okay, so essentially, you're gonna go through R, right? So in this example, the first you'll paint the cell inside of matrix that has value 1. So in this case, this one's the value 1, that's why it's painted blue. The next one you'll do is the one with value 3. This is the one with value 3, so that's why you paint it next. Then you do the one with value 4. You paint it with the one with value 4, and here you'll return 2, because once you painted the element at R in index 2, you had a row or a column that was fully painted, right? Here you didn't have a row or column that was fully painted. Here after painting the 4 you did, right? So the very first thing to note is essentially like, okay, one thing I want to be able to do is quickly perform the operation where it's like, okay, given an integer value in R, how do I know which position in matrix I need to paint, right? So I need to map all of the values in the matrix to their positions, right? Positions being an index I and an index j inside the matrix, right? So that's the very first thing that I do. Step 1, loop through mat and map value to position values inside of our dictionary D, right? Here I made D an array instead of a hash map, just because it's like, okay, since all the values are from 1 to m times n, we can just have like, you know, m times n plus 1 total indices. That way it's like, you know, using a key instead of doing it in a hash map, you can do it inside of the array, because like, you know, every single index from 1 to m times n inclusive will be a valid index inside our dictionary, inside of our array D here, right? But you can use a hash map if you want. It's still O of 1 time, but that's essentially how I got to a 97.48% submission rate, right? Because if I use something like the dictionary, for example, over here and here, if I made, you know, rows, comma, columns, both equal default dics of ints like this, everything is still constant time for, you know, adding, searching, and so on, or creating inside of a dictionary, right? It's O of 1 lookup, O of 1 push, O of 1 pop, and so on. Everything is O of 1 with a dictionary, right? But our solution is a little bit slower. So whenever you can use arrays, the O of 1 operation of looking up something inside of an array tends to be a little faster than the O of 1 lookup inside of a dictionary or hash map in Python. So that's why whenever I can make it an array, I do make it an array. And so that gets us to like, you know, that beautiful, so now we're at 79.49%. So yeah, we updated these and so on. So yeah, if we submit again, we might be able to get back to like, you know, the 90% ranges and so on. So there you go, 98.11%. So again, kind of like, you know, a little bit of variance all the time with the LeetCode solutions, but that's why I use an array instead of a hash map. But if you want to, you can definitely 100% use a dictionary, right? The point is to map values to the positions in matrix, right? So here we loop through all of matrix, right? M and n is equal to length of the matrix and length of the matrix column. So m is the number of rows, n is the number of columns. So here's like, okay, we have our array, which really will map, values to the positions of the matrix. So let's loop over all the matrix. For I in range m, for j in range n, we'll grab the value at that matrix position. So mat at I and j is that value. And we'll now say, hey, this value will now be mapped to position ij in the in the matrix, right? So that way, whenever we look up d with a certain value of val, we will map to the position ij, because that is where val is inside of the matrix, right? We're going to loop through the entire matrix. We're going to say, okay, for position ij, here's the value. Let's map that value to that position ij. That way, whenever we query a value using our hash map / array d over here, we will know which position inside of the matrix that value actually is inside of the matrix, right? So that way we can query that in O of 1 time later on, instead of looking through the matrix every single time, which would be super, super inefficient, right? So then from that point on, then step 2 is essentially like, okay, we recognize that we have m rows and n columns, right? We want to keep painting essentially until we either have painted a full row or a full column, right? So let's keep track of how much, the percentage painted for every single row and column every single time we paint a cell, right? And the way we're going to do this is essentially, we're going to create a dictionary again, but here again I used arrays just because I can, but again, if you want to, you can use a hash map / dictionary in Python. But the point is that, okay, we have m rows and n columns. For every single one, we're going to keep track of the number of painted cells among that row or among that column, right? So at the very beginning, here I use an array with m zeros for rows, because there's m rows, each of them having 0 painted cells at the beginning, and I have n columns, each of them having 0 painted cells at the very beginning, right? Otherwise, what I'm going to do is I'm going to loop through the array from left to right, starting from index, enumerate, just essentially like this is the same exact thing as this for for index in range r, val is equal to r of index, right? These 2 lines of code, essentially, you can think of it as the same line of code here. It's just, it'll give it to you as an enumerator. So every time you iterate over it, it'll get you the next pairing, which will always be like, the next index and the value at that index and so on. So it's just the same thing as this, just a nice short Pythonic way of writing things. So for each index alongside its value inside of our array from left to right, we'll say, okay, we have the value. We want to know what position, so for example, here's value 1. What position inside of the matrix will this paint? Well, we need to know which position in the matrix has that value. Well, good thing that in step 1 here, we mapped every single value to their position in matrix, right? So what are we going to do? Well, we're going to say, okay, we're going to look up inside our D the value, because that'll map to the position of the value inside the matrix mat, right? So here we'll say I comma j is equal to d of val, right? We have the value. We want to know the position at which this value is stored inside of our matrix. So again, we'll consult this array d that we built in step 1 over here and say d of val is where our position is located, right? So I comma j will equal to d of val. Now, once we have the position that d of val is at instead of mat, we want to effectively paint it, right? So since this is position ij, this means that the ith row will now have one more painted item, right? So we do rows of I plus equal to 1. And the jth column will have one more item painted inside of it, right? One more cell painted inside of it, right? So columns of j plus equal to 1, right? For example, when we paint the 1 over here, we'll say row 0 just had one more thing painted. And we'll say column 0 here had one more thing painted, right? Over here, we'll say row 1 had something painted. Column 1 had something painted. Here it'll be row 0 had something painted. Column 1 had something painted, etc., 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 right? So essentially, we have m rows and columns, and every single position that we find next inside the array, we'll say, okay, we're going to say this row has one more painted cell, and this column has one more painted cell, right? And at any point, the row that we just painted a new cell at, we check if it now has n painted cells, right? Remember, for each row, right? For example, okay, these are bad examples because it's 3 by 3 and 2 by 2. But remember, there's m rows, each with n columns, right? So each row has n columns worth of values, right? And each column has m worth values worth of rows, right? So if the number of painted cells inside of a specific row is n, i.e. the number of columns, because there's that many values inside of a row, or if that column has m painted values, because that is the total number of cells inside of a column, then that means we just either painted a full row or just painted a full column, right? And in that case, we just returned the index that got us to the point where we finally have at least one full row or one full column, or maybe both, like for example, in this case over here, that is fully painted inside of the matrix math, right? Otherwise here, outside the for loop, I raise an exception. The reason I know that I can do this is because in the worst case, you loop through everything inside of R. Since both R and math, have the values 1 to m times n, essentially the worst case, you iterate through all of the array and you've essentially painted every single cell in math. So every row and every column is completely painted. So, at some point you'll eventually find an index, right? So that's why I'm not worried. Like, here I'll eventually come across returning a solution. So this is me just being cheeky, like, okay, I'll never be able to reach this case because I'll always be able to find a solution, right? But that's pretty much it in terms of how I was able to solve this problem. So just split into 2 steps. The very first one is convert have a way to essentially map values to their positions inside of matrix math, which you can do so by iterating over all of the values inside of the matrix math initially. And then step 2 is like, okay, keep track of the number of painted cells for each row and column, and every single value that you iterate through in the array, you're going to grab, okay, what is the position that it maps to, right, using the value to position mappings that you built in step 1, and then essentially be like, okay, that row has one more painted value and that column has one more painted value, right? If that happens to be the nth painted value inside the row or the nth painted value inside that column, you now have either one fully painted column or one fully painted row, in which case you're done with the problem and you return index, right? That is pretty much it in terms of how I was able to solve that problem, and hopefully this solution makes sense. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I would highly appreciate if you left a like or a comment. But otherwise, I'll catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.